Okay, we're going to look at, or continue looking at parametric equations this lesson. So it's continuing from what we've already done. So if we wanted to find dy by dx, then remember we can differentiate x with respect to t, find dx by dt. We can differentiate y with respect to t, so find dy by dt. And then to find dy by dx, we were doing dy by dt times dt by dx. So remember, the dx by dt gets flipped upside down. Okay, the difference now is they also introduce another parameter. In this case, and in most cases, they call it p. Okay, all that means is that we're looking at points along a graph, and in this particular sort of situation, x is 2t plus 1 and y is t squared plus 3. So the parameter at the moment on those is t. But once we're talking about the parameter p, all we would do is replace the t's with p's. Okay, so it doesn't really matter at what point you substitute the t's for p's. I tend to work with t's initially and then substitute the p's in later on in the question. But it won't make a difference to your actual answer. Okay, so in this one, the first thing we've got to do is show that the tangent at the point P with parameter P will have this equation. Okay, and then part B, which I'll come on to in a moment, says the tangent passes through the point 2 minus 3. Given that the point P is in the second quadrant, find the equation of the tangent. Okay, well, if we start with part A, okay, and I'm going to write that again. We know x is 2t plus 1 and y is t squared plus 3. So because we're talking about the tangent and finding the equation of a tangent, we know that when we're finding the equation of a line, we need a point on the line, or graph, whatever it is, and we need the gradient, which is going to be dy by dx. Okay, so I can do dx by dt. Differentiating this is going to give me 2. I can find dy by dt, which is going to be 2t, and therefore using the fact that we've already done that dy by dx is equal to dy by dt times dt by dx, we're going to do 2t times by, and then we flip this one upside down, so it'd be 1 over 2. Okay, if we work that out, we're going to get dy by dx is equal to t. Okay, so using then, because we want to find the equation, using y minus y1 equals mx minus x1, we've got our gradient of a tangent is this, so we've got m equals t, and our x and y values are the original values we were given. Okay, so we've got our x1, y1 coordinate would be 2t plus 1 is our x value, and t squared plus 3 is our y1 value. So that's what's going to go into here. Okay, so putting those in, we're going to get y minus, I'm going to use brackets because it's all minus t squared plus 3 equals m is t, and that's x minus, and then using brackets, 2t plus 1. I'm putting it in brackets to be careful with the signs, obviously. You know, we need to be really, really careful with the signs here. So if we simplify both sides, we've got y minus t squared minus 3, okay, and then we've got tx minus t times 2t plus 1 there. So that's going to give us y minus t squared minus 3 equals tx minus 2t squared minus t. Obviously, like I said at the start, they actually wanted us to use parameter p, not t, so I'm going to make the substitution now. So using parameter p, now I could have done it at any point really, I'm just going to do it now. Using parameter p, all that means is I'm going to replace all the t's with p's, So we've got y minus p squared minus 3 equals px minus 2p squared minus p, sorry, not t, minus p. And then you should see, given that they wanted us to give it in this form, that all I now need to do is rearrange what I've got. Okay, so I've got I need px minus y, so I'm going to leave the px here, bring the y over so it becomes minus y, and then if I take everything else to the left hand side, I'm going to have minus p squared plus the 2p squared is going to give me p squared plus p minus 3, which is what we were asked to show.